Hi, I'm Sabrina Sartori from the University of Oslo. It is a pleasure to introduce you to Dr. Nancy Stoffel from General Electric. Thanks for being with us.
Oh, thank you.
Nancy, General Electric is involved in the development of a large number of materials and devices, for instance, flexible and organic electronics for future wearable patient monitoring. So, given the importance of innovation in industry, how do you view the role of applied and basic research, both inside companies and in universities?
Right now, we just put out GE Aviation is one of our largest business units, and we have announced in the last year a new engine platform called the LEAP engine platform. And within that, there were two major materials and processing innovations that took many years to come to fruition. So within that, there was a ceramic metal composite platform that was developed, which essentially allows the engines to work at a higher temperature and with greater efficiencies than a metal alone could work. And so that the expectation is that is going to increase fuel efficiency by being able to go hotter, and it will also allow for a lighter weight engine, and that is going to make a big difference in kind of fuel efficiencies. At the same time, within that same engine, what's also in there is an additive technology, parts that were made with additive technologies. So instead of the standard methodologies that we use to create parts where you do subtractive metal forming, where you start with a big piece of metal and take things away, these were built sort of from the ground up using new additive technologies. GE views that as being sort of a brand new industrial innovation platform. So both of those things were in these engines, and both of them were in the works at GE for more than 10 years, for quite a long period of time. And so this is the first place that this innovation is showing up within GE, but it isn't the only place. So GE has, because it is a company that has so many different broad interests and so many different businesses, what they want to do, that we believe that we can do, is we can leverage these new technologies, and we started out in aviation, but we're going to push them into power generation, we're going to push them into medical, we're going to push them into transportation and our oil and gas industries. And as we move through in those areas, we're going to be able to enhance efficiencies in power or reduction in weight in all of those areas. So for us, innovation, materials innovation is again, very key to almost any innovation that we make. And when we make these were examples of some very large investments that we made, and we need to be able to essentially reuse and move them through the programs. And that requires both people that are good at those initial technologies, and it also requires people that are expert in the application space that we're going to be using, so that we can change them as we go.
This I see more as applied research, so not really into basic research, or do you do also this?
So no, I would agree with that. So I think that the role of basic research once upon a time was sort of shared by both the academic community and by the industrial community. But at this point, I think that it really does belong pretty squarely in the academic community. And so I think that GE and most of the industries are really relying upon the academic community to make those big swings, to make those brand new introductions of materials or processing phenomena, or et cetera, that need to be done.
So you see as important the relation between the two communities.
The relationship is extremely important, and that needs to, that they need to develop the new things, and the companies need to be able to pick them up. And then there's that kind of place in the middle where they need to meet. GE is trying to find new models by which to do innovation. So we no longer believe that we can do it all of ourselves. So we have organizations within GE whose role it is to try to find new ways to innovate. So we have a ventures group, and that ventures group looks very strategically and tries to understand what small companies are doing. And generally it's the universities that do those initial breakthroughs. It's the small companies that kind of
like
spin out startups and start moving those things forward a little bit. And they need to develop the technologies more specifically in order for a large company to want to come along and be able to take it up and to be able to reduce the risk and reduce the cost. So part of what we're doing is we're looking at what is going on with the small companies and what's of interest to us, and perhaps we're going to invest strategically. Part of what we're doing is we are working collaboratively with governments and with these national manufacturing institutes that are being formed. GE is a big part of almost everyone that is out there that are at least aligned with our interests. And so those are designed to not to do the basic research, but to take the research that has been demonstrated to look feasible and to move those forward to the point where, to do the pre-competitive work, to move it forward to the point where companies within the United States can pick those things up and move them forward. And the goal in this particular case with that program is to manufacturing within the U.S.
You mentioned that General Electric is really interested in a portfolio of different innovative products. So what do you think are the hot topics for the future with the potential for major impacts in our life in the next few years?
So I'd say one of the very big things that is true for General Electric, probably true for most people, is we believe that energy storage is a really big deal. We think that the renewables, the means of generating energy with renewables, whether it be solar or be wind or other technologies, are fairly well developed, and the thing that is preventing them from moving forward and having a wider adoption is really to have cost-effective energy storage mechanisms. And I think that is really going to be sort of a big materials breakthrough that's going to need to happen. On a similar vein, the other things that I would say is, so I talked a little bit about the additive manufacturing and how that allows you to perhaps make some things that you could never make before, make them more cost effectively and faster. But right now, the amount of materials that are suitable for additive manufacturing is a very small number. It takes perhaps a year to bring a material through the development cycle in order to be able to feel confident that you could use it. We believe that understanding the physics of that additive manufacturing process better, understanding better what it takes to make a good material, and then being able to come up with new ways to create those materials and to bring them through this reliability cycle better would be really important, because this is going to be the new wave of industrial manufacturing. And in that process, there's going to be a lot more digital, a lot more modeling, a lot more experimentation, a combination of the modeling and the experimentation that's going to happen both in the initial pre-design, into the design, and then in through manufacturing. And that's one of the things that GE is really trying to do right now. We're trying to transform ourselves from not just being a heavy industrial company, but being a company that has a lot of a digital thread sort of running through the entire product range.
So GE is an international company. So if we look globally, in your opinion, are there geographical differences on how innovation is perceived in the world, in different companies in the world? What is the approach of innovation in companies which are outside US, for instance?
So global research once upon a time was primarily based in the United States, and right now we have research centers all over the world. We have them in Asia, in Shanghai, in India, in Brazil, in the United States, in Europe. And part of the reason for that is that we believe that because we're servicing people all over the world, that it's important to have people working in a variety of countries, and that in some cases they can better serve their country. For example, in China, in Shanghai, there is a program called In Country for Country, where people are looking at the large medical imaging products that we make here in the United States, which are really too expensive and too large for application in China, and they're modifying them, and they're saying, okay, what would sell here? What works in our infrastructure? How would we do things? And they're coming up with new products for use in China, and in fact, many of those products are then getting rolled out in other places.
Well, thank you very much, Nancy Stoffel, for being with us. From Sabrina Sartori, thank you for watching.